Welcome to Analytics with DAX. This is the end-to-end DAX video where I'm going to explain about the basics or fundamentals of DAX and moving on to explaining different business scenarios to use appropriate DAX functions. And why I've taken this topic is because this is the most requested video in this channel, and I understand the complexity involved in learning DAX functions. This is because people started learning Power BI and they understand each and every concepts in Power BI. The only place where people stuck in Power BI is DAX, right? So DAX is little tricky. I agree, because while I started learning Power BI, even I faced the same thing, same issues that everyone currently or whoever learning Power BI is facing. So how I approach DAX is like I gone back to understanding about the basics or fundamentals, when to use appropriate DAX, whether it should be calculated column or whether I need to create a measure, and understanding about the appropriate data types that DAX function is accepting. So those fundamentals are really help me to write a better DAX functions. So this is why I created this video, and whatever I'm going to explain as part of this video will definitely make you to help and write a better DAX functions in the future. If you are new to this channel, hit the subscribe button and press the bell icon for notification, and do share this channel with your friends and colleagues, and so that whatever the work I do will reach as many people as possible. With this note, let us begin. Let's check it out. What are all the topics that we are going to cover in this video? We'll start with introduction, and we will try to understand why we need DAX, like it's used to create measure, calculated column and calculated table. DAX fundamentals is so important because why people are struggling in DAX, because they don't understand the fundamentals. So we will focus on the fundamentals like syntax, naming, operators, data types. Then moving on to how DAX works, like filter context and row context. Then we will talk about how calculate function is going to help us in doing all the magics. Then moving on to types of DAX function. So it is also important, once you are familiar with fundamentals, what are different functions we need to use based on different scenario. So we will start with aggregate functions, date and time functions, time intelligence, filter functions, relationship, followed by logical and text functions. Once we cover all these types, there are a lot of other types, but main focus, most of the projects involve we can able to achieve it using this. That's why I thought of doing this as our predominant functions as part of this video. And finally we will conclude with whatever we have seen today. This is the agenda. Let's begin with our introduction. Let us begin with introduction about DAX. DAX stands for Data Analysis Expression, which is a library of functions and operators that can be combined to build formulas and expressions used by Microsoft BI tools. Basically, it contains a collection of functions. On top of that, you can apply some operators to create formulas or expressions. That is why DAX is used for. And it is also known as a function language, because her whole code is kept inside the function, because you will write a lot of functions. You will call or use a lot of functions already pre-written by Microsoft. The way you write DAX is you choose correct functions that perform certain operation, right? That is what a DAX is used for. So once you notice this word, used by Microsoft BI tools. So what are those BI tools? So once you learn DAX, you can use it in Power BI, Power Pivot for Excel, SSAS tabular model Azure Analysis Service. So those who have started their career only in Power BI, they may think like DAX is used only in Power BI, but DAX is used a decade before in Excel itself as part of Power Pivot. Power Pivot and SSAS tabular are the logic behind how Power BI runs at the backend. So once you learn DAX, you can use in all these BI tools. With this introduction, let's move on to what is the purpose of DAX. By using DAX, you can add three types of calculations to your data model. So we have seen what is DAX. It contains a lot of functions, and we can apply some operators. So by doing why we need to use DAX, when we need to go for DAX, because you create a data model, you bring the tables and drag and drop the visuals right in your Power BI or any model, then you will get the chart. Then where DAX exactly used? In order to create a new calculated columns, right? You have a table with 10 columns. You need to create additional column in that. In that case, you need to use the DAX, like first name, last name combined together, or a sales quantity into discount price, how much it was there. So like that calculations you want to do, then you will need to go for DAX. Then measures, as it indicates, it is used to give you the value it will execute at the runtime, like sum of sales, average of your price, all those things will be calculated using measures. So these are called measures. For this, in order to create measures, you need to go for DAX. Then finally, you will use DAX for creating the calculated tables. You have a 5 to 6 tables, you created star schema. Using that, you are not able to solve your business problem. You need to combine or create some derived table or calculated table, right? Using combining the two tables, and you create a new table, or from a single table you create aggregated table, like that you want to create. For that also you need to go for DAX. So using DAX, you either create calculated column, measure, or calculated tables predominantly. There are some other purpose also you will use DAX, like RLS, other parts, but 90% of the work involves creating of these items. Okay, then now it's time for us to understand what is the calculated column versus measure. So you can see here the calculated column, as we discussed in the previous slide itself, expands table by creating a new column. So when you create first name, combine first name and last name, then it will create a new column. So it will expand your table. When you create a calculated column, stored along with the table. So if it contains 10 columns and assume there are 1 million rows, then for that 1 million rows, the new column also will be stored. So it consumes the memory. It contains less analytical capability. So mostly it will be like addition of 2 columns, calculation, simple multiplication, subtraction, those kind of calculations you can do it using a calculated column. Whereas measure, when you will create a measure, summarizes a data into single value. So it's like numerical value. Usually measures will be created on top of the numerical value. What are numerical values? Like quantity, sales amount, your unit price, what is your discount price, right? These are the some of the your numerical quantity. For that you will create a measure. What it does, it summarizes, right? Summarization can be anything. It can be sum, max, min, average, anything, right? And it will give you a single result. It will be calculated at runtime. Unlike calculated column, this will not be stored in the along with the table. Just calculations are stored, okay, only logic. Then once you drag and drop the measure in your visuals, at that time only it will be executed. It contains rich analytical capability. Some of the examples of calculated column. So you can see a new product. It is a product table where if you combine product item and product category, then it becomes a new column. Similarly, you can also create a profit as a new column dividing sales amount minus cost amount, that will give you a calculated column. These are some of the examples. Some of the examples of measures. You can see total sales, sum of it. As I said, it will summarize, it will always wrap around one function like sum of sales amount. This is the column name. This is not a fully qualified name. We will have a table name along with the column name. This is just for a demonstration you want to understand. So sum of sales amount, this is the column name. This is a numerical value or column data type. Then again another example, sum of sales amount minus sum of cost amount. This is another example of writing the measure. So before that, the final example, as I said, one of the feature of measure is rich analytical capability. As you can see here, you can create the previous year sales comparing the current year versus previous year sales. For doing that, it requires a lot of efforts when you are not having a good analytical tool. So here, this same period last year, as you can see, it calculates the sum of sales amount. Same period last year, when you see by year 2010, 11, 12, 13, you will get the sales amount in one column. When you use this measure in another column, right, I mean in a table, when you are viewing in a table, so this will give you for 2011 2010 data, previous year sale, right? So this simple function will have a capability. This is what a DAX is, a function language where all the code kept in the function. Calculate is one function, sum is another function, same period last year is another function. All these things are functions. You are just calling it, okay, with some reference of your columns. Then all the logics, whatever it is predefined in the by Microsoft, right, they have written a code what calculate should do, what sum should do, what same period last year will do. So all these functions require some arguments. For same period last year, it requires date column. For sum, it requires a numerical column. For calculate, it requires an expression, and then followed by some columns, right, filters. So these are the some of the syntaxes you should aware. So I hope this is what quick introduction about calculated column and measure, and in our practical example we will see and demonstrate how these two are different. Then as we said before, DAX is used for creating calculated column, measure, as well as a calculated table. When you will go for calculated table, for creating a date tables, role playing dimension, what if analysis. So role playing dimension, if you are not aware, just go and watch my playlist, that data warehouse concepts playlist, where a single table acting as a different role. The best example is date, like due date, ship date, and order date. All those things are columns in a fact table. These are some of the things you will get to know once we practice DAX, but just you want to understand like what is calculated table. It is a derived table you create using a DAX. So these are the main purpose you will go for DAX. Let us start discussing about fundamentals or basics of DAX. We'll start with syntax, and before that, the key difference between Excel and DAX I want to clarify, because those who are from Excel background or those who heard in online, DAX formulas are similar to the Excel formulas. That is what they heard, but there are some key difference. Why? Because Microsoft Excel, you can reference individual cells or arrays, okay, meaning like you can reference E5 plus F6, like that you can reference individual cells in Excel. But in DAX you cannot reference the cells. It is either you can reference a table or columns as the DAX function argument, okay. That is what a main difference. And also some of the data types, not all the data types supported in Excel are supported by DAX. What are the data types supported in DAX? That I will cover a couple of slides later. Now let us discuss the syntax. The syntax is very simple, like this is a simple DAX formula where total sales is a measure. So in this case DAX is used to create a measure. So measure is what it does. It is summing up the sales amount column. It aggregates the value sales amount and it will be stored here. It is not stored the calculations, only the you are instructing the Power BI or the Power BI engine, whatever tools behind you are using, SSIS or analyst service, you are saying calculate sum of the sales amount. This is what you are instructing, and the syntax is sum of is a function and fact sales is the table name. So table name contains the space, so you put it within the quotes, single quotes. Then a column name is wrapped within the brackets. The entire code, the column reference, right, it is within the parenthesis of this sum function. So sum is the function, you are putting just argument as the column name, the sales amount is the column name. This is the simple syntax for your DAX function. So we need to understand the naming in order to better write the DAX codes. Basically you can see the table name without space, you can write it like this, sales, and if it contains some space, you can write within the single quotes. And you people say like fully qualified name, meaning like the column reference you are doing, you need to reference a table name along with the your column name within the brackets. So it's a column name or measure name, both are similar, you can see over here. And if it contains space, as you see, the table name is within the single quotes, and you mention the quantity, that is the column name. Operators, those who are from the programming background, they may aware what is the main purpose of operators all about. You want to do some calculations, addition, subtraction, or any other arithmetic operation or comparison, right? You need to go for these kind of operators. So these are the different operators supported in DAX: arithmetic operators, comparison operators, text concatenation. So the people will confuse with ampersand and and. So ampersand here indicates concatenation, and in order to verify logical condition, you need to do two comparison, right? Then you need to quote double and if it's for logical or condition, two lines over here, right? However it's shown. I hope this is more or less so basics. Let's move on to data types. So data types are building blocks, like it's very fundamental for any programming. So similarly, DAX supports following data types: text, whole number or decimal for numerical values, and date and time, true or false, boolean. So very limited data type sets, not so much. Okay, so you can see for numerical values, whole number or decimal, and for text it's a free text or general, you can say it's a text. For date and time related thing, there are three things: either date time or separately date and time. For boolean, you have true and false. So these are the data types supported in DAX. We have seen the introduction and fundamentals of DAX, and it's the time for us to understand it in the real world, how we will use DAX in Power BI or any other tool. Throughout this demo, I'm going to use the AdventureWorks database, and if you don't know how to do it, there is a video I have made long back. Just go and check it out. That will be in the SQL Server playlist, how to upload AdventureWorks. So you should have a SQL Server AdventureWorks database, and then you can connect to Power BI to practice along with me as part of the demo. So this is what I'm saying. So this is my server. I have AdventureWorks data warehouse. I have downloaded from internet and I have restored it in my server. And this is my Power BI, which doesn't contain anything. It is an empty Power BI file. I just launched and keeping it for you. Now let's try to connect to this data source. That is, my data source resides in SQL Server. So I'm connecting it. It is // my server name, that is Naga SQL 2019, and I can just click on connect, so that it will use my credential. I think it is not Naga's girl, it is in caps. That's fine. Let's see what it happens. Use my current credentials. We are unable to connect to data source using to access this data source encrypted. Click OK. It's saying some encryption. That is fine. Now this is my data. It's residing here, and you can see what are the tables I need. As usual, I will go for fact, internet, sales, and I can use the select related table, so that fact and dimension are created relationship in the database. It will fetch it up, and in this I do not want to fact, internet, sales, and I have other dimensions connected here. So I am going to load all these tables. These things, if you are already familiar with Power BI, and it will be more familiar with you, and the intention of this video is not you to teach you Power BI. Main focus is on DAX, so let us not worry about whatever data it is or whatever source it can be. Okay, so now you can see in here where you have your fact table surrounded by your dimension tables. And why I am showing this window? For writing DAX, you need to understand what kind of relationship exists between the tables. You see, the customer and fact is one to many, and whereas the dim date, one of the column like due date is connected as active and other columns are inactive. We will come to this later, but for your understanding, it is called a role playing dimension where a single date table is connected to fact table multiple times. These things we will come to that later. Now first things first, we have loaded the data here. Now what we want to do, we already seen the main purpose of DAX is to create a column, measure, and a table. We'll start with the column. Let's go and check it out, the dim product now. So this is the data that exists for the dim product, where you can see you have a product alternate key and an English product name. What I want now is like, I want this product alternate key and the product name to be combined. Okay, so for that you can click on this table and new column, right? You can choose the like this, or in you have options to add columns over here as well. So as soon as you do that, you see a column appear. It is what the DAX code you are going to write. So here you will say new product name or product name new, whatever it can be. Okay, just I will place it like this. Here you are going to combine the columns, right? So it is full reference, right? As I said before, it is you are referencing the table name, and within bracket you have a column name. It is a fully qualified name. So product alternate key is the one you want to has a first argument, and then you use ampersand symbol. As already we seen, ampersand symbol is a concatenator here, so it will concatenate. In between I want to add some symbol here, okay, hyphen. So for that I use the double quotes. Again I will use the ampersand symbol. Then what is the name? That is English product name. So I will type English product name. Just type ENG. You can see the IntelliSense displays all the values matching. Okay, that is that displays all the columns that starts with or that contains ENG. Now this is what the code is. Once you press enter, you can see here the alternate key, right? I will try to move this one. I'm not sure whether I can move towards left. That is fine. So now you can see these two columns, right? The product alternate key and English product name, that has combined and created as a new column. So this is one typical simple example of creating your calculated column. There are lots and lots of examples, like you can create first two characters left off to create some subcodes, right? So those kind of things you can have it. The main thing you was analyzing here is like, what you need to understand is like, the calculated column preserves memory. You see, for each row of this table there is one entry made here. Okay, this preserves memory. That is the one point you need to highlight. This is what a calculated column is. Let us start discussing about a measure. So measure, when you see here in Power BI, the columns that doesn't have as a sigmoid symbol, which is nothing but it can be a text column or it is a reference to another table, and whatever you see as a sigmoid symbol, which is nothing but your measures. Typically Power BI, it may be considered as a internal measures, and sometimes if it is some numerical values, it will be designed as a, it will consider as a measure like zip date key. It doesn't it is not actually the measure. Okay, so in those cases you go and change the aggregation for this. Okay, definitely this is no more going to be the aggregation. Okay, don't summarize these columns, is not required as well. So this is the first point I want to make. And you can see here we will focus on two things. One is order quantity and sales amount. Okay, let us try to have a new visual for sales amount, and I will do it as a label, data label. So you have order quantity and sales amount, and we will try to increase the category label as well, so that it will be visible to everyone. And I will do the format by tab, and I will choose background color slightly. So these two are considered as measures, and you can able to see it. And often we can also write a measure like this, like total sales, sum of sales amount. Okay, that is what is that? Sales amount. Now I have written this measure. Okay, now let us try to have this measure against over here, and I will do the same formatting for it. So what is the difference between this as well as this, writing this, right? There is no technical difference. This sum of fact internal sales that explicitly I created, and this one, okay, this is pointing to the base column, the sales amount, does the same thing. There is no performance impact or nothing. The only advantage is like assuming everywhere, okay, in your report there are 10 to 20 reports, and in the same report, it's different pages, and everywhere you refer this sales amount. Suddenly what happened, the column name got changed or it got collapsed. So all this, and maybe instead of sales amount they put sales underscore amount. So what happened at that time, all the 100 places you need to manually change it. But when you write it like this, right, what happens, you are not going to have any impact. Sum of fact internal sales amount, right? Here you, instead of sales, this particular total sales is referred 100 places. So instead of changing 100 places, you just come over here and change the newly changed column here. That's it. So all other 100 places will be automatically filled. That is the only main advantage of writing. So to come back to our main topic, what is a measure, when to create it? So these are one of the main reason you need to create explicit measure, even though I say whatever sigmoid symbol, aggregation symbol exists is a measure, right? And another difference, as I said before, when you go to the product, here all your newly created column contains each row has been stored in the memory, whereas in fact internet sales, the column that I created here, it's not a column, a measure, the total sales will not appear as part of your table, right? It is not part of your table, the data is not stored anywhere. If you write this code, this data not stored, only if you drag and drop. Okay, when you drag and drop in this table like over here, and you want to analyze against some group, at this time only this query will be fired and you will get the results. Okay, so this is what the key difference about your columns and the measure. So it is not when people at the beginning stage they will ask me, so always it is better to write a measure. It is not the case. Most of the aggregation type and calculations you will go for measures, but these kind of concatenation, as we did before, some column derivation, right, these things you need to go for new calculated column. Okay, so both have a difference, and for that you need to choose the respective one. But you need to understand this measure is executed only when you use it in a visual. When you remove it, it is not stored anywhere, and only if you use this visual here, I mean the measure here, at this time only this calculation is executed against each row here. Okay, the filter context will work. I will come to that later, what is filter context and row context. So with this we will stop about calculated column and measure for introduction purpose, and we will go to next topic, calculated table. So one such example for creating a calculated table, maybe most of them I have explained separate video in modeling for handling role playing dimension. Here you can see here now the data is related. Okay, now related using the due date. It is not actually a due date, it should be mostly order date should be the key factor deriving it. But what happens when I want to analyze by using the, I want to filter, okay, filter the data by due date. So now this is related using the order date. Okay, order date, and based on that order date I have connected the dim date. Now when you filter it, then you can whatever you filter, that will filter the order date, corresponding order date column. But I want to filter by based on the due date. Okay, for that sometimes the role playing dimension is the perfect solution, but for due to some reasons we may want to create some duplicate table. Okay, for that how you can create. So let us go to your home, okay, the table tools, and then you can go to new table here. So one way to create a table is like, for I'm going to create a dim date table here, dim date underscore due date. For due date I'm creating a dim date table. I can just type date table as such. This is one way of creating, like just when you put enter, okay, this will create me the entire table, copy of one table here. That's it. So once you go and check over here, dim date due date, it's nothing but dim date is repeated as such over here. This is one way of creating. Otherwise I have another way for I'm creating a new table in another method. Okay, just go to tables and new table. Let us try to create another table for ship date, okay, or dim date underscore ship date. So here I can write a code as well. How you can write? Date of, okay, I can say like, or I can use the calendar. You can see like calendar, start date and end date. When you give this calendar start date and end date, it will create a column. You can see returns a table with one column of all dates between start date and end date. That is what I want. Okay, here I need to use the date function. Let's try to create 2 years data. It contains more than for demonstration purpose I'm creating. Let's try to make it like 2021 1. Okay, This is the date, that start date parameter I'm giving. Press comma for this comma. We have given the start date. Similarly, end date you need to press 2021 12/31. 2 years I'm simulating. Okay, I'm giving this entry. Once you press enter, you can see a table is created, ship date. You just go and check it out here. So one column is created, and again you can derive it one by one. So you can create a new column here, year of this particular date field. So you can put year. Okay, then you can pass the left hand side is the column name, and here you will mention the parameter date. So year of date, which will give you the name. So this is nothing but hold on, year name. What happened, you need to provide the full name. Okay, you have multiple date column, it get confused. So we are creating for ship date. Let's try to create it for it. This is what you can say, fully qualified name. Again you can press the another function and the your column name. So this left hand side is your column name, and this is the function that is passed. I mean, it gets this column as a reference, I mean the parameter, then gives the corresponding year value here. That is what it is. Here you can rename it like name. Okay, for your understanding, year underscore name, to understand the difference between the name column. So you see, whatever you give, that will appear here. So this is how you can create the derived column. There are some functions that creates your table. Okay, like one I showed here, this calendar will create, and you can copy another table using just referring that another table, or you can use the summarize column functions. Different table returning functions will be used to create the tables. So these are the main three reasons you will use DAX, either creating calculated column, or creating a measure, or using the calculated table. And one important fundamentals we need to consider is the data types. So basically, like DAX functions are more connected to data types. Like you have aggregation functions that requires only the numerical data types. That column, I mean, it gets the column reference that is of numerical data type. So some text functions like concatenate, all those things will require text data types. So data types plays a major role. To demonstrate, I will go with one of the example. Right. So now let us see. We have some numerical data types in this product, like days to manufacture, and we have English name and French name. You can see the data type of it, this particular column. Like we will say that English product name, the data type is text, and you can see like what are the different data types it can hold. You cannot change a text to whole number, that will create a confusion. Even you can see that sigmoid symbol, if it is sigmoid symbol, then it is like either it can be a whole number or a decimal number, so that it can be aggregated. This indicates some aggregations can be applied on top of it. So this is what very important thing to note. And you can see something with this symbol like date time, or date will have denoted differently. So date time means you can see the different data types. So what is the main point I'm trying to convey here? So what is the main use of data types? Now let us see. I will create a new measure for the sum of English product name, and what will happen. Let's try to create sum of product name. Okay, so you are trying to use this sum function. Okay, you can see the column name in doesn't say odd, adds all numbers in a column. Okay, it adds all the numbers in a column, but what I'm trying to do, I will put English product name here. Okay, so dim product of English product name. What will happen? So some product name. Now you can see a new measure created here, that is some product name. what will happen, there is no error while creating, but as soon as I drag and drop this measure here, okay, it throws me some error. What it throws? Calculation error in measure dim product sum product name. The function sum cannot work with values of type string. So here only gives you the actual error message. So a sum cannot take a column with text data type, right? So what is the text data type? You can go and see here the dim product, where the product name, English product name, contains only the textual columns, right? So it will not sum it up. So the same measure, okay, I will go here and have some other numerical data type here, like list price, sum of list price. Okay, this is just for demonstration to understand, okay, the way you will not create some measures in the product dimension. Just for understanding, I'm demonstrating it. So instead of English product name, I am using the numerical value here, list price. Okay, and let us try to hit enter. So as soon as you enter, you can see there is a data over here. So this will sum up all the list price of across the all products. So this is what you need to understand. So for each function, it takes certain columns, and that columns should be of particular data type. Like string functions will work only with string data type columns. The numerical functions, the aggregation function, will work only with your numerical data type, like integer, the whole number, or decimal. Okay, that only it will take. That is what I want to ensure. Even you see, like, you are adding some date data types, date add of, date difference, and parallel period, previous period. So all those things takes only the date data type. So you need to specify only the date columns in those functions. So that is why your data types of the columns are so important, and you need to ensure you are passing the correct column with the proper data type to that function. With this note, we will move on to our next session. Let us start understanding about row context versus filter context in DAX, which is very important concept to have a deep knowledge on DAX. So let's begin with row context. A row context does calculation for each row with the values within that row. Meaning, like, you are doing some calculations for each row in your table. That becomes your row context. Example is over here, like sum x sales amount minus cost amount. What it does is, like, for each row it will do this calculation, right? The sales amount is one column, cost amount is another column. For each row it will do the this calculation and give you the result. This is what a row context is, as simple as that. Whereas the filter context is set of filters that applied before the table arrives for use. Okay, what it mean? You have written this formula, like total sales, sum of sales amount. Okay, sales is a fact table, sales amount is a column, sum is a function. Then applying filters from filter pane, visuals, slices. Okay, example, from filter pane you applied 2017, and from any other visual you applied country as India, and slices you applied city Chennai. So after applying all these filters, okay, this table will be filtered. Sales, say for example, without any filter, it contains 1 million rows. For this combination, only 0.5 million rows are there. For that 0.5 million, you do this calculation, okay, then it becomes your worked on the filter context. This is what the filter context is all about. You apply all the filters, get the small table or filtered table, then do the calculation. That is what a filter context is all about. Let us see that in practical examples. Now we have seen the definition of row context and filter context. Let us try to check it out in Power BI to understand it much better. We are in Power BI now, and this is very simple table. You can see the table visual, which we are viewing the data against sales territory group total sales. Let us try to add some more filters here to understand much better about filter context first. Then we will move on to row context. Now let me have this English occupation, and let me put it here in the filter pane. I will change it to filter and slightly increase the size of this filter data as well, and also increase the header size. Okay, now this is the total sales. Now this is giving me the total sales of the entire table. You can see the fact internet sales, total sales, that is 29 million, right? And the same total sales I've used in this table, but it is showing me the different results. How it works? This is what a filter context is. So basically, in this case, the total sales is split by territory group, Europe. This is one filter. This is filter number 1. And as soon as I click on this clerical, this also reduce the data, right? You can see the for clerical it is 3100632. So meaning like a filter context is nothing but set of filters, filter 1 and this is filter 2, which is applied to arrive to the result. That is what a filter context is. So it is not only this particular Europe is deriving this result, also other filters, right? This is filter number 1, this is filter number 2. Then you also apply some other filters over here against each year or particular country you want to apply, or any other product color you want to apply. All these filters are applied to derive this value, right? That is what a filter context is. So it is as simple as that, and each filter in DAX world is considered as a one filter table. Okay, and all this table, filter table, combined together forms a filter context. Basically, to rephrase, like this is the total record 60,398, and when you sum up the sales amount here, right, this sales amount, which will give you the 29 million. Whereas when you click on this clerical as well as for Europe, how it derives. For clerical, I mean to say the filter propagates from here. This is why the relationship is important here. The clerical or the occupation remains in this table, right? The dim customer over here, the English occupation in this customer. How this flows to fact internet sales, that is what you create a relationship, and you see the filter propagates from dim customer to fact internet sales, the propagation from here to here, right? So this is one filter, and this, once you click on one filter like English occupation, that is considered as one filter. Then again sales territory, that remains in another dimension. Where is that? Here. So sales territory group, that is also applied as another filter. So you will have two filters now. Filter 1 is your dim customer, English occupation, and then filter 2 is your sales territory group. So these two filters combined called as filter context. So, and in this filter context, right, Europe is the value. For Europe you will have, this is the sales amount. For North America, this is the the filter context changes here because the value is North America. For North America clerical, this is the value. So like this you need to compute. It is nothing but set of filters applied to derive the filter table. From that you will get the corresponding results. So this is what a filter context is. And what about the row context? So row context, as the definition says, the calculations is applied for each and every row. That's it. So you can see the definition here does the calculation for each row with the values within that row. So basically, like you can write one simple measure to understand. So I will have new sum x here. I will write the profit. Okay, profit is the new measure I'm creating. Like over here I will write sum x, and I will need to refer the table fact internet sales, and I'm going to apply sales amount minus product cost, fact internet sales total product cost maybe. So what it does, for each row in this fact internet sales, this calculation is happened. I mean, this calculations will be calculated. So that is what a row context is. So let me put enter, and I will use the profit over here in the same table, and you can see for each territory group you calculated the profit. So how it works here is like, you can have this fact internet sales, and for each row the calculation, the particular sales amount minus your product cost should calculated for each row, because for you can see like the product cost for one particular row item is different for another product. So you cannot have the total sum of sales minus total product cost, right? You cannot get the profit. You need to do certain calculations each row, because the product A cost is 50 and you are selling it for 60, and another product B cost is 70, you selling it for 80. So you need to subtract these two records, then you calculate the profit for each row. You cannot sum up all the sales amount and all the product cost, and you cannot subtract total sales minus product cost. For these type of calculations, you go and apply the row by row calculations. Okay, so this is what a row context is, and you can see this calculation, the profit calculation, happens using the sum x. The sum x is the iterator that will loop through each row in this table, and for each row, once you specify, you can specify the column names directly. Otherwise, for all other calculation, you have seen sum of column name, right? Here, once you have a table level information, you can specify the column reference directly. There is no need to wrap it around sum or average functions. Okay, so once you refer a table, you can refer a column. So you are referring two columns, sales amount minus product cost. Now you may ask me, once I apply this clerical, whether this fact internet sales will be filtered or not. Yes, so basically once you apply filters, external filters here, this table will be filtered, then these calculations will be happening. That is why it will be faster. So you are doing this calculation for the filter context. So first filter context applied, and this table is reduced to clerical only, then you will get the calculations done for each row. So let us try to check it out. Once you click on clerical, the profit also calculated only for clerical with the filter context applied. So this is what your row context and filter context is. Next we will move on to our calculate function. Let's start understanding a calculate DAX function, which is very important function in DAX, and let us try to deep dive into it. So basically the calculate function evaluates an expression in a context modified by filters. This is the simple definition of calculate function. We will try to understand with some simple examples here demonstrated, and we will move on to our Power BI and understand it much better. Now, as the definition says, evaluates an expression. So what is that expression? This calculate takes an expression. This is your expression, that is sum of sales amount, in a context modified by filters. So basically, like as I said before, this is the filters modifiers. You are modifying the filters whatever applied. Say for example, in the country you applied some filters, right? Say for example Europe, or some other country, Australia, that will ignore whatever filters applied, and this will calculate only for the United States, irrespective of whatever filters you applied in your page or external slices. That will be ignored and it does the calculation. Similarly, over another example, does the evaluate an expression. So calculate, evaluate sum of sales amount for all the dim country in that column, right? It consider all the values in this country column. So whatever the filter context applying, ignore those, calculate all the values in this dim territory country. So let us try to understand it much better if you didn't get it in this explanation. Let's move on to Power BI. So we have a similar or same table here, and let us try to have a country here instead of our territory group, so that it will be much clearer to you. So we have a country over here: Australia, Canada, France, Germany, United Kingdom, United States. So let me remove the profit. We will focus only on total sales. Now what I'm trying to say here is, like, I want to calculate the United States figure and I want to compare it across other countries, right? So how much percentage difference between Australia and France against the United States. So in order to do that, for each country I need to get the United States here, right? So such a comparison can be done only if you use this calculate function. So let us try to write the get the United States sales first against each country, then we will try to calculate. So first is like new measure, then instead of just writing the sum of sales amount, we will say US sales. This is the measure name we will provide over here, that is US sales, and then we will have a calculate function. So you see the intelligence automatically popped out here. Let me zoom in so that you will understand it better. Calculate, then I will write the sum of sales amount, that is over here. Let me start writing sales amount so that it will appear. Then here is the catch, where you are going to write the United States sales. So where is that? That is sales territory country equals United States. So start writing it. It should be there is no I mean, it is more case sensitive, so if you write wrongly it will not give you the correct result if you misplace the spelling as well. So I hope this bracket is not required. So dim sales territory country equals United States. So once you press enter, then you can go and click on this visual over here. There you go. Now you can see here this 9389790 is repeated for all other countries as well. So this is what I said, it modify the filter context. So what is the filter context of this particular cell? Well, let's say like clerical. So even if you press this one, okay, so what is the filter context here? Clerical as well as Australia, then this is the result. In case of this particular measure, that is US sales, this is applied, this filter context is applied, whereas the Australia filter context is modified, because you are saying whatever filter is present in this column, that is filter context, ignore that, but you consider it as United States. So Australia is no more is applied here, and you are saying for if in this column you consider the United States, so it is like modified filter context. So you are modifying the filters here. So this is what the United States says, and it will ignore whatever filters applied here. So for all this values it is repeated. So why you need to have such values? You want to do a comparison between the Australia sales and the US sales. What is the difference between these two? So in those cases you need to apply such a measure, and then you can apply difference in sales percentage or whatever, right? Let us try to have it make it simple. We want difference between total sales of US minus Australia. So how you can do it? Let's try to write the new measure which says difference in sales, difference in sales, whatever it is, US sales. I'm saying this measure, that is what you need total sales. Now you can see both. Then you can have this different sales measure over here in this table, and you can see the results over here. So I hope you understand what I'm trying to make here. Like let us try to have 2 decimal places, not to have more, so it will avoid a confusion. So now you can see a proper difference between these two. Like US, for each country you are getting the difference, how much difference compared to United States. So such a difference you can make only if you are making the code like this, right? So that is what the main purpose of this calculate function. Let us try to have another example here. Like instead of your US states comparison, I want how much percentage contribution each country has made against this total, right? So for that, how you can write? So let us try to have a copy of this measure, and I will say all country sales. Okay, let's have like a new measure. So how you can get the contribution or proportions or percentage contributions, like for each row here, each country, you need to get this value here. Then you use the divide function of your total sales divided by your Australia sales, then you will get the results, right? Same thing we are going to do. For first step is to get the all country sales. So here again you are modifying the filter context. So here I am not going for US sales, calculate sales amount. Instead of United States, I am saying like all country sales. So for that you include all. So you are modifying the filter context. Here if there is any filters applied in this country, ignore that. Consider all the values. Last time we consider only the US values. This time you consider all the country values. That is what all function does. So these are some of the functions you use, okay, that modifies the filter context. So now once you press enter, now we will have all country sales here. Now once you have this, you can keep it here. Now you can see 64684,784. okay, that is repeating for all the countries. So ignore about this NA values, we will talk about that later, but for now you can see this is applied, this total value is repeated for all the countries. Now how you can do the percentage difference? You can either create a new measure, or with the existing measure you can do it. If you want to do a comparison like this, then you create a new measure like percentage contribution of each country, percentage contribution Okay, I'm just writing a short form. Okay, that's fine. I completed. Percentage contribution is nothing but your total sales. Okay, divided by all country sales. Then use the percentage format. Okay, there you go. So the Australia contribution is 16 percentage and the France contribution is 20 percentage, and you can see Germany contribution is 22 percentage. So you can see how much contribution that each country has made. So this is why you want to do the the context, modify the filter context, right? Why you want to use calculate and why you want to transition the filter context? Because sometimes you want to do certain calculations that requires overriding your filter context. The filter context should not be applied. In those cases you will go for calculate. That basically the definition says modify the filter context. So you are modifying the filter context. Whatever we have seen before, like row context and filter context, which will apply external filters along with the internal filters in the chart, then it will give you the result here. This works as a filter context. But in this case, you are modifying the filter context. You are getting the total value here. Not this filter is not applied for this, right? You get all the values and showed here, then you divide it using this calculation. So this is what a calculate function does. It accepts the external function, external filters, because you are not used the columns over here, English occupation. You are using only the calculations for the country. You are modifying only the filter context for the country. So other filters still is valid. Okay, that you need to understand it. I hope this is fair enough to understand when you need to use the calculate function. And this is very important. Once you understand it, you can able to write any complex logics that should be used by calculate function. Now we have seen like DAX is used to create calculated column measures and calculated tables, and we have to understand what are different types of DAX functions available. It's grouped under some types, right? Something like aggregation, time, and some financial functions. So what are different types available? Let us try to check it out in this session. So different types of DAX functions, like aggregation function, as we are already familiar with, sum, minimum, maximum, average, all those things are primarily most of them will use. And date and time functions, I will just quickly go through that. What are those functions? Time intelligence functions, more powerful, like YTD, MTD, total YTD, and then other time intelligence functions, filter functions, financial functions, information, logical functions. Okay, so these are different types of DAX functions available, and some other things mostly not used in all the subject areas. Maths and trigonometric functions, parent and child function, relationships are used when you have, it's like the aggregate function, date dimensional functions are by default, most or 90% of the projects will use the whatever you see in this top 4. Other functions are used as and when is required, like relationship, table manipulations, text functions, right? But if your data is more onto text, you are focus on text. It's not all the projects will have textual data, right? So these are some of the DAX function types. Now the point is like you will have around 250 DAX functions fall under these categories. So do I need to understand all those things, right? That is the question. So you can go through this reference over here. Okay, this is the where I referred these types of function. And to answer my question, like whether I need to know all these 250 functions, the answer is no. No one knows all these functions, because there is no way like everyone in their projects in the real time they will implement those functions, right? Only the situation comes, they will go and create it. So that is what I want to make. So but in saying that, do I need to know some basic or predominant or primary functions so that I can able to handle some projects, right? The answer is here, the most used DAX functions. What are those? Aggregation function like sum x, average x, min x, max a, count, distinct count. Then followed by a filter function, you have a calculate, filter, all except. So you can take a screenshot of this. So once you are familiar with these functions, you can able to handle most of the projects. So this is first list of functions, and other things comes with it for time intelligence and date time, like total YTD, total QTD, and first date, last date, year, month, day. So once you are familiar with these functions like related, relationship, is blank, has one value, summarize, group as, treat as, rank x. So these are my favorites. Most of the projects I used. I definitely say there are other functions also I used in my project, but those are not predominantly used. Whatever you see in this list, the most used functions in my day-to-day projects. Now we already aware all these types of functions exist in DAX, but it is practically impossible in a single video to combine all the DAX functions, which will definitely confuse you, and it is not recommended as well. So what the plan is like, in next part of the sessions, what we are going to see is like all the functions highlighted in red, right? Aggregation, date and time, time intelligence, filter, logical functions, relationship functions, and text functions. We're going to cover these topics, and in these we will touch upon some of the functions in each category. That will clarify you or give you an idea how you can use different functions based on the different business scenarios. With this understanding, you can able to answer or handle any of your business scenarios. With this note, let us try to start with aggregation functions. So what are aggregation functions? Like basically you have a transactional data and you want to see the data in the aggregated manner. Like, so what are those? You have a sum and count, average, max, min, and distinct count. So these are the different aggregation functions available. Apart from these five, which are highlighted in red, you also have other aggregation functions which are rarely used, and some cases most of them will use count rows or count blank as well. So when you are from SQL background, you might be familiar with these things. It's a typical group by of your calculations or table data, and you need to use some aggregation along with that. So the sum, count, average, max, minimum, which is easy to understand. But in case of DAX, you also have something like sum x, count a, or count ax. So what are this a and ax version or x version of it? That also I will try to cover as part of this video. Let's start with understanding this aggregation functions. So basically, like what is this reporting everything is all about is like you want to see the data at the higher level or aggregated level, right? So you have your fact internet sales over here where you can see there are 60,000 records. So seeing the records one by one doesn't give you any statistics or analysis, right? So what you need to do, you need to model in such a way that, and you need to derive or generate a report at the higher level, each country wise what is my sales, and each occupation, which occupation is contributing more, some kind of aggregations, right? That is what you will do. So what are the aggregation functions available, right? So let us try to start with the basic measure. We can say this as the inbuilt measure, where you can see here sales amount, that is implicit measure, right? So when you drag and drop here, it is a column. By default, when it is aggregated, it is not showing one by one. As soon as if you see here, this is the textual column, customer PO number, whereas when I drag and drop this one, it will not aggregate anything, it will show first off. Okay, it is not doing the any aggregation, whereas whichever the numerical column, it will do the aggregation. So where is the aggregate, how it is calculated as sum? You can see here, the by default it is aggregated as sum. So these are the basic aggregation. By default, a measure is attached to one aggregation. You can see all the numerical column, or you can change this behavior. Okay, for the sales amount, you can change this behavior. Instead of sum, I want to do the average of sales amount or average of count, right? So those kind of stuffs you can change it over here. So this sales amount as having aggregation is sum. So this is what it is set now. In case of order quantity, it is calculated as sum again, because order quantity can be 2 or 3 quantities for each product, so it also to be the sum. So this is the aggregations, the basic aggregations you have over here. You might ask me, like, by default the implicit measures are calculating the sum. What is the point of writing the explicit measures like this? You can see here, this is again doing the same. The total sales is the measure name, which is doing the same operation what we have seen here. We are using the implicit measure. Like over here, what we are doing, sum of fact internet sales, sales amount. This is called explicit measure, where we are writing, the user is writing this calculation. Now I use this explicit measure here, which is again showing the same results. Okay, the core difference, or from the developer perspective, what is the advantage you will get is the performance perspective. There is no difference, it is more or less same, because you are using implicit measure or explicit measure without any calculate function wrapped around it. The performance remains same. But when it comes to the developer perspective, assume you use the implicit measure, the direct columns all over your calculations everywhere. Around you have like around 10 to 20 reports, right? I mean 10 to 12 pages in this report. Then if this column name is changed in your source system or something has happened, then all your 20 pages or whatever reports, wherever you are referred this one, it will be failing, it will not reflect. Whereas if you use explicit measure, once you fix this measure, right, instead of sales amount, in source system they change sales underscore amount. Once you fix this explicit measure, wherever this explicit measure is referred, everything will be automatically reflecting. So from the developer perspective, this is super performant and efficient to fix it in a single place. So that is why always I recommend you to create some explicit measure even for a simple measure like this, and then you can hide this measure. This is what my recommendation. So now I told you, like, this is implicit measure where I drag and drop the base column, and also I can use the explicit measure. This is very clear. So let me walk you through the base measures by using implicit measures itself. So this is average, so which saying about average sales in Australia. This is across over all the years. When you click on 2013, this is the average sales in Australia. So this is about average sales. Then you can also have a minimum sales. That is, in Australia the minimum sales happened is 2. We can click on different year so that we can see any changes happen. I hope it will change for maximum. So when you change to maximum of your aggregation of sales amount, you can see 3578 across all the countries it's same, but when you click on different year the value changes accordingly. So the data is like that. So that is why you can see the same maximum amount for all the countries, but when you click on different years you can see the difference. In 2014 is the last data available, so that is why you have the maximum sales amount is 159, whereas in 2013 2443 is the maximum sales amount. So when you click on a particular quarter, or I think the data is duplicated repeatedly, that is why you can see the same number repeated. But when you see for 2014, the actual maximum sales amount for Australia is 159. So this is the basic aggregation type. You can change between here. Either you can use from the, if you use implicit measure, you can change here some average, minimum, maximum, or count, right? Count of total records, and especially the count is used based on the invoice number. So basically this is for, you can set the sum of sales amount here and how many records has happened, right? For that you can use the sales order number, and here also you can see this is set as sum, so this can be changed over here. So this is another important factor, like this aggregation. When you set here, when you remove it, okay, click on it and set it here, this will be applicable for all the visuals. When you drag and drop here, you see this aggregation by default it will be count, but there is a provision to change for you as well. Okay, so this is the another point I want to highlight. Now this order number, meaning like there are 332 total records in Australia. That is what happened in 2014. When you uncheck it, so there are 13,000 records in Australia. This is the total sales amount. That is how you can control the aggregations. So these are the basic aggregation: sum, average, minimum, maximum, count, and I will talk about distinct count as well. Like usually distinct count will be counted like how many products sold. So for that you can drag and drop this product key. Okay, this is related, that is why you do not have any symbol here. So just you can use the count distinct. So count distinct, when you put here, there are 158 distinct products sold in Australia. When you click on 2013, it will be filtered to 2013. In 2013 there are 1 or 2 distinct products sold, and there are 11,000 transactions, and this is your total sales amount. That is how you can see the results. So as I said before, you can either create the implicit measures like that or explicit measures. This is the core aggregations part. In upcoming part of the video, we will try to understand sum x and max x, so that max a also, so that you will understand when you need to use the core measures and when you need to go for x or a version of the core measures. Now let's try to understand this x version of sum, when to use it. So basically, like you have this sales amount. Let me remove other things. Okay, and you have sales territory, country wise total sales over here, and in order to calculate the profit, right, let me have a profit that we have already written. We need to use the sum x. Why? So profit in this business, it is total sales amount minus total product cost. Profit is like for each and individual item you need to calculate the profit, because sometimes for each transaction there might be discount might be applicable, because the profit calculation, why you cannot sum up the total sales, you cannot sum up the product standard cost, because for each product cost is different. For each transaction, how much profit you have got, that you need to calculate. That is, you need to calculate the profit row by row, then you need to sum up the profit. That is what I'm trying to convey. So for these kind of operations only, you need to use the profit over here. This sumx function will go to this table and then subtract the sales amount minus the product cost for each row. So this x function is nothing but your iterator to the table. It will go to this table, whatever the expression table. It can be a filtered table as well. So go to this table, filtered table, then do this calculation. Then whatever calculations you do here, that will be summed up. So here for each row, it will subtract the sales amount minus product standard cost and calculate your profit, right? Then sum up this column. Let us try to understand the max A and max x, and we will move on to other types of functions. So first max. So let me create a measure here, new measure. So max, as the formula indicates, it gives the maximum amount from that column. So let me put that sales amount here. So fact internet sales amount, and you can see the definition returns the largest numerical value or string in a column. Okay, basically it takes a column and it ignores the logical values, meaning like if it is a boolean data type, it will not be considered. That is the code difference. I have demonstrated this max in a separate video in the DAX playlist. Just go and watch it. So now I'm used this max. Now you can see I can use this maximum sales here. So which indicates for each color what is the maximum sales amount. This is what it is. When you say the definition of a function, let me take this one. The definition is remains same. Largest value in a column does not ignore logical values and text. It will include the logical values. So if max a is used when you want to have a maximum from the logical values, that is the boolean expression, then in that case you need to go for max a. I do not have any logical values now, so I'm ignoring that. Let's move on to understanding the max x, right, when we can use it. So here you have a maximum sales. Max s is the iterator, as you can see from the definition. Returns the logical numerical value or largest string that results from evaluating expression for each row of a table. So here you can have a filtered table, then you can get the maximum value. So typically, like when I use fact internet sales and then comma, when I have your what you call the sales amount, okay, the sales amount, fact internet sales amount, I can use this one. So what is the code difference? You can see here is like maximum sales. So again the result remains same, there is no difference, right? So when you use max and max x of the actual formula, the result will be same because of the filter context applied. There are also filter context applied, then you will get the results. Max x is used when you want to do some filtering over here, right? So as you can see, assume I want the maximum sales here. I will just copy this visual, okay, and I will revert back this one as max and leave it for max, okay. Let it be max sales. I'm going to create max x sales measure, new measure. So here I will paste it, max x sales, okay. Here what I'm going to do, I want to do a filter of this fact. So filter this sales. Okay, I want whichever sales amount is having more than 1000. Okay, here you see 49 is the maximum amount of your multicolor, right? Here what I am saying sales amount should be greater than 1000, then only whatever having the whichever records having sales amount greater than 1000, okay, get those maximum records. Okay, from that above 1000, whichever is having the maximum value, show me those values. That is what I'm saying. Say for example you have 500 records, out of which 200 records having greater than 1000 sales, right? So from remaining 300, so like I'm confusing, I will repeat again. Say for example you have 500 records, out of which 200 records having 1000 greater than sales, right? 1000 sales. Then get those records. From that records, get me whichever is maximum value. I don't want anything less than 1000 as a maximum. Okay, now when you enter it, now you can see here I use this one. You can see the beauty here. Like I ignored whichever is not having 1000 because the table itself filtered for those sales amount greater than 1000. In that case, in multi, the maximum sales amount earlier, okay, without any filtration, it is 49 is the maximum. But why there is no records? Because in this calculation you will get only the records having only 1000 greater than sales. Okay, so you ignored that. So such a calculations you can go for max x. So row by row operation, you ignore that base records itself, right? Core the fundamental or the after evaluating the filter context, then you do the calculations, right? So this applicables whenever you click on any year, you see based on the different year it will work properly. So this is what it is. So now you got the point about the core functions about sum, count, or max, average, min. These are the core fundamental functions. As and when required based on the different business scenario, you need to go for sum x or max x, or based on the a, or if it is mostly related to text or something like logical values, then you need to go for a functions, which is meant for the string or logical handling. I hope this is clear about aggregation functions. I have a separate playlist for DAX. You can go through all these functions once again. Let's start discussing about date and time functions. As you can see on your left hand side, most of the date related functions, and here you have time related functions. Basically like weekday and week number also usually date related, but what I'm trying to say is like these are commonly used. Mostly the granularity of the data will be at the date level. Some rare cases, some business requires only the time related calculations. That is what it is. Let's start discussing about the date related function. We already seen a calendar and calendar auto while creating the table. So these two functions used to create a table. As we already know, DAX used to serve three purposes: to create measure, to create a calculated column, or calculated table. So these two will create the calculated table. And some of the functions like day of, which requires the date field as the input. Only if you provide the date field you will get the what day it is, right? So these are some of the column level functions like date, which requires the date as the column, as the input. That is what it is. Let's start understanding about some of the functions so that it will be clear to you. As you can already see in here, this ship date or dim date ship date has been created using the calendar function. You can see here calendar, and once you create this calendar, date of 2020, it will generate 2 years data. That's what it is. And you can generate the year column. On top of that, you can also create the quarter column, like which quarter it is, right? Quarter of, month of. So you can keep adding those columns functions here. Let us try to create the quarter. So here, quarter of that date field, right? So date, dim date, ship date. You can mention the full name, ship date dot date. Then you can close the bracket. There you go. You can see it belongs to the quarter 1, and when you move towards down, 6 belongs to quarter 2 and 7 belongs to quarter 3. That is what it is. So that is what these functions are useful. Similarly, you can create month of, all those things. Let's start try to understand these two functions, now and today. What is now and today? Let's explain. The key difference between now and today is now includes the time. So you can see now, okay, when you close this one, it doesn't require any what do you call any inputs. Just now means it includes the current timing as well for along with the date. This is now. And what is today? Today will create the only the new date column. It will not include the time. Let us try to create a new column for today, or I can name it as current date. So I will include, that is the code difference. So when you will use, based on your business scenario, when your business requires you to filter based on this timing, right, then you need to go for now. But today you can see only it will give you the date 000. Okay, this is the code difference between now and today. That is what you can able to solve. And one key factor I want to highlight is like date difference. People now confused with what do you call, how you can write it as DAX functions, right? So basically, let me move on to fact internet sales. So what we can do is like we will start creating the difference between order date and ship date, okay, using the date diff function. And this date diff function takes the two parameter, that is two date columns as the input, and gives the difference between those. So that is the syntax. So what you can see from here is like you will start creating a column, then you will understand what I'm trying to say, like why people are getting difficulty in writing DAX as a column or as a measure, why they confused. We will start creating the column now. So I will name it as shipment day. Okay, so it is basically days, that's fine. And we will start writing it as date of. So it requires two date columns. Okay, now when I start typing the order date, that is a column, it will start appearing here because the date diff function takes the two columns. So in calculated column, you can refer a column by typing it. Okay, it will start appearing it and you can use it. And one more difference here, you can see the shipment date contains only the date, and here you can have the order date contains the time also. Okay, so we will go for a day. You try to maintain the data at the day level, not at the time level. So once you click on enter, it will start creating the difference between order date and the ship date. And as I already aware, like this column contains the same difference. Okay, the order date and ship date. That's why for all the rows you will get 7 days as the difference. Okay, and even at the bottom, and for all the records, let's try to check it out at the top. See, for all the records it is 7. So the core idea what I'm trying to say is like the dateDiff function takes two columns. When you create a calculated column, you can directly refer those two columns easily. Okay, that is the point I want to highlight. But what happens when you are planning to create it as a measure? That is, I want to calculate the date difference. Then I create it as a measure or not? Okay, what happens when you try to write it as a measure? Let's try to go and check it out. Let's go to the report view. Then I will start creating the measure here. So now the measure, okay, I will name it as dateDiff as a measure, dateDiff measure. Now dateDiff, when I start typing fact, I'm not getting the column reference here at all, because this is measure definition is it will return a single value. Okay, so it the calculation should be wrapped around within a function like aggregation function, sum of, or calculate. Okay, those kind of functions it has to be wrapped around. When I start with the sum of, now you can see when I start typing the sales, now it will appear the order date or the column reference is appearing. So this is what I want to highlight here, like which function where you can use. Okay, but you can use this function within a calculate function, calculate sum of sales amount, date diff of. Okay, in that filter context, I mean when you have a filter inside a calculate, there you can use the date diff, but here it is not possible. That is the point I want to highlight. The power of BI tools comes with very easy to write some complex calculations easier. So in that manner, most of the business wants to analyze the data using time calculations like current month, previous month, current year, previous year comparison. For that, we need to write complex logic in Excel or any other conventional tools. So the power of Power BI comes with this time intelligence functions. You need to write a piece of code so that your current year, previous year calculations or time related calculations will be more simple. That is what we are going to see in this session. So what are those functions? You can see total MTD, QTD, YTD, parallel period, previous period. You can see all these names are self-explanatory, and there are other uncommonly used functions: next day, next month, next quarter. Most of the business uses MTD, YTD, QTD or previous period, same period last year. And in as and when cases, you can use some of the functions like first date, last date. It depends upon how people use the code, right? So, and if you are not aware of all these functions, I will give you some of the examples so that you will understand what we are doing. As I said before, we have a dedicated DAX playlist. I have explained each and every function clearly with how and based on business scenarios. So this video will give you overview of it. So if you want a deep knowledge, just follow that DAX playlist. Now let's move on to our Power BI and check out some of the functions. So as I said before, what is MTD? First, you need to understand what is MTD and QTD and YTD. For that, let me drag and drop the full data alternate key from the table, and I use the sales amount as the key factor of it. So basically, like let me increase the font size of it so that it will be easy for everyone to understand and view it. This is column headers, and I need the values also to be little bigger. so that people can see it properly. Yes, now it's better. Now you can see here from the table where you have each day, like from January, we will consider from January 2011, the day, each day sales is appearing here. What about the cumulative sales, right? That is what MTD. If it starts from January 1st and ends on January 31st, that is MTD. And if it continues till the quarter, that is what QTD. I mean to say January 1st till March 31st, what is my total, right? That is quarterly cumulative total. And on next quarter, it will change it to, from this date it will be 10532. Addition of this will give you the result here. Let me try to create some quick formula so that you will easy to understand it. Let's start writing MTD. So new measure, I will say sales amount MTD, sales MTD. I will say just sales MTD, no problem with that. So the formula is very simple, total MTD, and you start typing what you want the total MTD. You type it as sales amount, right? So I want sales amount. So here I think you need to use sum of sales amount. If you already defined the measure, you can use that one, total sales. Otherwise the expression means the calculation, it should return single value. That is what expression is. Sum of sales amount I want as a MTD. Which date, based on which date? I need full date alternate key. So fact internet sales, that is full date alternate key. Let me type full date alternate key. Okay, now use this one, and I need MTD only. Just press enter. Now we can use this measure here, and you can see here from the total, let us not have any the decimal places. Let's keep it as none for this. So let me categorize as none. I don't want to be any decimal places. Let it not be a currency, let it be some decimal number. That's okay. Now you can see it is not summing up. Why? Because this is another important issue I want to highlight. Let me quickly highlight it little later. Once you click on this, right, dim date dot alternate d, you press dot here. Okay, here you use the hierarchy. Okay, you used hierarchy means you need to use the hierarchy from this dim date. I will come to that issue later, why, when you need to use the dot date, when you should not use the dot date. Okay, I'll come to that. So now you can see from this diagram table, this is summed up with this second date, and you will get the 22,161, that is 7,000 plus 15,000, which will give you the 22,000. This 22,000 summed up with 14,000 the next day sales, which will give you the 36,000. So this is what the MTD is. At the end of the month, you can see what is your total sales. So cumulatively you can see your data. So when you view it in a graph, you can see it properly. You can see as a cumulative across the month, right? In each, it should not be viewed as a month. Let me filter out some of the year, then we can see it properly. So let me filter out one of the year, calendar year over here. Let me filter out as list. I will filter 2013. Let me increase the size over here. This is perfect, and let me go down one down further. Now you can see from the diagram, so it is MTD. See, January 1st, the data is over here, and you can see till January 30th it is keep on increasing, right? Because each day sales is added to the previous day sales. As soon as you reach the next month, the February, let me increase the size. It is very small in size, you can't able to see. So as soon as you reach the February 1st, you can see the date here, that quarter 1 February 1st. Okay, the sales again start decreasing. I mean to say, it's not decreasing, it will be like 1st of February sales and second this month MTD. So that is what the MTD is all about, and as you can see, that is what happened over here. So this is the example for MTD. Similarly, you can do it for QTD and other YTD functions. So you can see here total MTD is this, and same thing I can copy and paste and see what happens to QTD. QTD means till that quarter. Here till the month end it is summed up, and the next month it will be again recalculated, right? What happened to QTD? Let's try to understand it. New measure, I will go for QTD. So I will, instead of MTD, I will say QTD. Okay, that's it. So sales QTD I will use as part of this visual. So what happened in this QTD? So same thing happened here. Let us try to make it as a decimal number, and we will not have the decimal places. Let's make it as 0. So QTD calculation is like you have a cumulative total till the month, and then along with that January, MTD ends here. Whereas you see in QTD what happens, along with this MTD, I mean the month value, the February also added, February sales, it keep on adding because the February falls under that QTD, that is the quarter to date. So till when it will be added, you can see till March 31st it is added. Again on QTD, what happens, the next quarter begins, the value changes to the beginning of that quarter, then it will keep on adding it. So this is what the calculations, usually you need to see the trend, how it's growing or not. Even in the COVID cases, you can see flatten the curve, meaning if your sales is keep growing, it is good. If in case of COVID, the curve should be flattened, the each day cases, new cases should be reduced or less, so that the curve is flattened. In our case, in the graph what we have seen in these new sales, it was increasing. In the case of sales, a business, the growth should be more, right? In case of COVID, it should be less, the curve should be flattened. So that is what people say about flatten the curve. Now forget about all these things, the MTD QTD, you understand about it. Similar functions you can start writing, like current period, previous period, parallel period. The one important aspect I want to highlight is like about dot date. Why I have used dot date in this chapter, right? I mean in this calculations. Now you can see here from this as soon as you import the tables, you can see whichever date column you have. I'm showing it in the dim customer. It creates a date column, one hierarchy. So what is this hierarchy means? For each date column identify in your entire model, any table, right? For each date column, it will create one internal table, that date table. That date table is referred here in your calculations. Either you can refer that date table or that particular direct column. What I'm trying to say, if you see here in this dim date, a full date alternate key is your date column, and which is having a hierarchy also. Okay, either you can refer it directly as full date alternate key date, okay, as a date column. Otherwise, if you refer hierarchy, then you need to refer dot date. What I'm trying to say. Now go back our calculations like sales MTD. Here you can see dim date dot full date alternate key dot date. Okay, I have used the hierarchy because dot after dot, when you press, it will display a lot of columns here. As you can see, dot, you can see dot date, day, month, quarter number, quarter. This is like you are referring a table of that column, okay, internal table of that column. Then you refer and keep that as a dot date. Okay, now that's why when you use here you use the hierarchy. Okay, here you use the hierarchy. That is why you got the answer. I mean to say, here you use the hierarchy. That's why you got the MTD value. What happens if you are not using this hierarchy? Let's try to see here. I will remove this hierarchy. Instead of this, I will keep this alternate key. Now as soon as I choose that table, okay, here in the table, I mean in the table visual, I'm using the column directly. I'm not using the hierarchy. Here you can see I'm using that column hierarchy, I mean column directly. Okay, this is full date alternate key. I'm using that column directly here. What happened? The MTD QTD values becomes null because in the formula I have used dot date. I referred the hierarchy. It is some other table. It got confused. So if you use, so how you are going to use your visuals, okay, based on that you need to code it properly. If you have had enabled that option, I will quickly show it to you. Why for all the date columns you are getting the internal table. Okay, now so how you are going to use, whether you are going to use the date field as such like this or hierarchy, based on that you write the column here, I mean calculations here. So now in the same formula, when I remove dot date for MTD alone, let's see whether MTD start working or not. When I press enter, now I'm referring the column directly. There you go. Now you see the MTD works fine, but QTD doesn't work because it's still referring to that hierarchy table, internal table. So this is the problem. Okay, now whether we should have that internal table or not for all the columns, this is performantly inefficient design. Okay, that is, if you are having a date column in all the most of the tables like start date, end date, it is recommended that you should not enable the hierarchy by default. How can you avoid it? So go to file and options and settings, click on options, then go to data load. Here you have auto date time. So what it is, if you see here, automatically creates a hidden date table for each field in the model, okay, that has date or date time data type. So whichever column has date or date time data type, it will create hidden table. If you have 10 columns in different tables, 10 internal tables will be created, so that will be performantly killing. So just uncheck it, then press OK. This will definitely improve your performance. So once you click on it, you see this is collapsing because you see the QTD has referred that internal table which is no more exists, because you can see that full alternative date key doesn't have. In customer we have seen a birth date, it is also went. So internal tables, everything is gone. It will be acting as a normal column. So your calculations should be fixed. So it is better all these things you do before creating your measures. So uncheck that option so that all your table does not create your internal tables for each state table. That is the first step. Then you create your calculations without dot date. Okay, there won't be any more internal tables, so you can directly refer the date column. This is the most of the questions people ask me. So now you can see both calculations are fixed. So this is the one of the important thing I want to highlight as part of this video. I hope you are clear with all these things. Lot of other function, each and every functions I have explained in the DAX playlist. Just go and refer it. So this is more powerful functions which will save a lot of your time. In this session, we will look into filter functions, which are most powerful functions in DAX. What are the different functions available in filter functions category? All those things listed over here. And whatever highlighted in red, that is all except calculate, filter, keep filters, lookup value, selected value, are most commonly used filter functions, and other things are used as and when required. Let's try to understand the filter function when we need to use it, and based on some examples you will get it better. Let's jump into Power BI. Now I have a simple example here. Like for each calendar year I have a sales, so it is not ordered based on calendar year. That's okay, fine. You can see here in 2010 2014 you have a sales. Now you want to compare this total sales or how much sales happened in United States and what is the percentage. In other words, the requirement is like, make it simple, what is the percentage contribution of United States against the total. That is what you want to get. In order to get that percentage, you need to calculate the US totals against each year. It is not against each year. Once you write a formula, you can use any filters. Either it can be by calendar, it can be by customer group or product, anything that will works fine. That is the power of DAX. Now first we will try to write how to get the US sales, right? So people think like those who are not aware of DAX, they will use sales territory as a country here and they can filter it, right? United States. But then how you will get this value total sales against this one, right? Each sales, that is not possible because this is United States, but they want to compare what is the total value of United States here, and you need to divide United States sales with total sales. That is what we want. Once you filter it, the entire visual filters for 14833. You do not have option to get total sales. Okay, that is a problem you will get. So there are different ways to achieve it. One of the best way is to remove this one. No need to worry about it, using a calculate and filter combination of your DAX function. Let us try to write it down. So I already made the function here, the US sales. Let us start writing it again so that people will understand. So sum of sales amount, so which is available in the my fact table. This is what I want to calculate. Okay, that will be wrapped around the calculate function. Now as you can see from the syntax, the expression will return the scalar value, and here you will have the filter as the filter. As soon as you type filter, the filter function, the syntax over here, it takes the table, returns the table that has been filtered. Okay, so you are applying this calculation, okay, that is sum of sales for the filtered table. Okay, filtered for what? United States in our case. So where is that United States available? That is available in the dim sales territory. You put comma and then enter, then you can call that sales territory country. I mean refer that column and you can press United States. So this is simple formula and pretty much clear about the definition. What are functions we used? We use calculate, that is to calculate some value based on the filter applied. So when you want to apply some filters, then you need to wrap it in a calculate function. So this is the filter function which will filter the table, that is United States. Now when I use this formula here, okay, now you can see this is the United States value for 2010 and this is the value for 2011. Now I can compare and get the percentage contribution of United States against the total, and I can analyze these two measures against any of the dimension. Okay, by product, how much US has contributed against the total, by different regions, right? Now against I mean, it's not against region, I'm saying by different products or different current customer geography. Okay, by different dimensions I can use this same formula and I can compare the how much US has contributed against different dimension. That is the core concept behind this DAX formulas. Once you write it, it is applicable for all possible combination of filters. That's fine. Now coming back to our question, so how to calculate this percentage? It is US sales divided by total sales, which is written using here US sales percentage. I used a divide function. Either you can use instead of divide, if you use US sales divided by actual fact internet sales total sales, this is also a way of writing it, but the problem I will highlight. So now you see, if you have anything with 0 in the denominator, it will show the divide by 0 error when you use a slash as a divider. Instead you need to go for divide function, which will handle the divide by 0 errors. So that is the core concept behind it, and you can put the comma. So numerator and denominator it will ask. So you can see this once you put divide, the result is same. You can see that is 1.4 million from the 5.8 million is absolutely 24%, around 24.6%. That is what it is showing. So this is how you use the filter function in order to get some proportions from the total, or you want to show only that US sales somewhere over in your calculations. So this is what we will use it here. Let me get rid of this and let me go back to another example now. Now this is fine, but another requirement, the second requirement is like, I want to analyze this, right? I want to analyze this sales instead of total sales. Whatever I filter in the dim territory country itself, I mean, like what I'm trying to say here. Let me drag and drop country here. If I choose country Australia, against Australia, how much US has contributed? Bit difference between these two, right? Total sales and what is the sales of United States. How I can want to compare these two results. How I can do that? Right, that is what the next requirement. Now what happens now, if you noticed, when I choose a country Australia, you see the US sales is empty. Even you choose Canada, the US sales is empty. When I choose United States, the data appears in the total sales and US sales. When you understand this particular concept, then most of the calculations you can able to handle when it comes to filter function. What happening now? Let us try to understand it. Now you see here the calculate function calculates the sum of sales. The filter as I said, it will filter the table with this particular country applied. So what happens when I choose Australia? First of all, this filter context is applied, so this table is filtered for Australia. Then it is trying to filter it for United States. So you do not have any record, single record, where the transaction of that particular I mean to say a single transaction, it will be tagged to either Australia or United States. You cannot have both, right? You are saying that record is Australia and United States. It is not going to happen, right? So when you choose Canada, it is the same case. France, it is the same case. Meaning like this filter is applied. This dim sales territory is filtered for Germany. Then this filter is internally applied to this fact table. So in the fact table you are already filtering the records only for Germany. After that you are applying the United States filter. So there is no transaction that can happen in Germany that will also happen in United States, right? Because each transaction tagged to one sales territory only. So how to handle such a scenario? You need to, what is happening here, the filter context is applied to this table. That is the problem. So whatever filters applied to this table, do not apply it. The all function will override that filter context. So when you put filter of all of dim sales territories, any filters applied in this table, don't consider it. Either from here or in this table, all are filter context. Do not consider any filters. Ignore all the filters. Then consider only United States. Once I put all here, okay, then I press enter. Now still it shows United States because there is no filters applied here. When I choose Australia, you can see the data appears here. Why? Because the Australia filter is not applied, because the filter what are applied, don't consider any filters outside, consider only this filter. So only United States is filter, meaning like all the records in this table is considered, and then United States is applied. That is why we put all. So in using this, you can able to compare how much contribution or what is the difference between the Australia sales and the US sales. So this is how you need to understand this filters. So when we move back over here, you have seen all, calculate, filters, all these things are more or less same if you understand this concept behind it. And I have taken in deep about other functions, all except keep filters, lookup value, selected value, all other things. Just go and watch my DAX playlist. Because of time constraints, I'm not taking all the other functions in this video. Let's move on to our next topic. It is time for us to check some of the logical functions. The list of functions are available here. As you can see, which are highlighted in red are most commonly used, like and, or, not, if, switch and true, as well as false and coalescent functions also used very often. With some examples, let us try to understand when to use these logical functions. If you can see in our previous example in filter logical filter functions, we have used US sales, right? So now the business wants the yearly sales or whatever sales happen against any dimension they were measuring. When they measure it, if it is greater than 10k, right, then it should be good year for them, that is good. And if it is less than 10k, that is for example, okay, then it is a bad year. So how we can define that, right? So you have defined the sales, then on top of this you need to write one measure. So excuse me. So basically what you need to do here is like you need to start writing new measure, and you can see like I can say good sales or bad, good or bad, maybe we can say like good or bad year. Based on that we can say, okay, then this is the name of the measure. Then what is the criteria? If the total sales are, it is the based on the US sales. Okay, if US sales is greater than 10,000, we cannot have anything with 10,000. Let me make it as 20,000. That is, for example, I told, if the US sales is greater than 20k, then make it as good, otherwise it is bad, right? So this is what we want to achieve it. So this is the if condition which checks the logical condition. That is why named as logic. So if the sales is greater than this, then display it as good or bad. Now you can start using this measure. I will make it properly good or bad here. And if you use this measure against here, okay, what happens? You can see, as per the condition, it is less than 20,000, then it considered as bad, and it is everything is greater than 20k, then it becomes your good year. So this is how you can write your conditions. This is why it is called as logical condition. Based on each row, it is testing and give you the result. Now when to use the AND or OR conditions, right? Let me introduce another measure here, that is Canada sales. It is same like your US sales, and I will introduce it. And in this case, what happens is, like, let us try to fix this or change the logic here. If the US sales is greater than, or I mean say, if US sales and Canada sales is greater than 10k, then only you need to consider as good year, meaning both US and Canada should be greater than 10k, then it is good, otherwise it is bad. So in that case, how we can write is like, so let us try to change the condition. US sales is greater than 20,000, and how to write another condition, right? So you can press AND here, I mean to say start typing AND. It is the different way to do it. So it will test the first logical condition, then comma, that is Canada sales, right? I have used that measure here. This is Canada sales. This also should be greater than 10k, okay, something like that. It is greater than 10k and Canada sales greater than 10k, then it is considered as good, otherwise it is bad. Let's try to press enter. What happened now? The result is same because of this condition. Let us try to slightly alter this. Instead of Canada sales to 10k, if it is greater than 2k, that is fine, then it is considered as good. Then what happens? Now you can see everything turned to be good, and this also turned to be good. We will not focus on these totals. We need to ignore these totals when using these conditions, okay? That is fine. I mean, even if it is applicable at the total level, then this is condition is true. Now what is happening? For US sales is true, and the Canada sales is greater than 2000, it's true. Both conditions satisfied, then the true condition is evaluated, otherwise the false condition. Let me write a condition. Instead of this, either one of them satisfied. Now both are satisfied, then only it turned to be true. Let us again move back this one to 20k, right? And it becomes bad now because the Canada sales is not greater than 20k. And now either one of them is true, like either US sales is greater than 10,000, otherwise Canada sales is greater than 20,000, then it becomes good. In that case it becomes OR. This is like typical your schooling concept, like AND OR condition. Either one condition satisfied, then it becomes true. if both conditions satisfied, then it becomes true, means you need to use and. Either one of them satisfies true, then you say it as good, true condition, then you need to use or. So let me put or here. Now what happened, that is this condition satisfied now, so it becomes a good year. This is what it is. Now let me summarize it. So if is logical condition used to test, and or is used when you have a multiple conditions to test, and if both should be satisfied, then you need to ask, and either one of them should be satisfied, then you can use the or condition. Now let me revert back the initial one, like and condition, either one of them should satisfy. What happened now is like, now US condition is satisfied, but this Canada sales is not greater than 20k for year 2010 and 2014. That's why it is bad now. Now if it is the case of this output, I want to reverse this. I'm meaning like whatever it is returning, now this condition is not satisfied for this particular row, then it becomes false. Whereas in 2011 both conditions satisfied, US sales is greater than 10k and Canada sales is greater than 20k, then it becomes good. But I don't want such output, I want to reverse the output. I will use the not, meaning like if it returns true, make it as false. So when you put the reverse, you just keep watching it, all the bad becomes good, good becomes bad. I entered it, so now you see the first two conditions become good, rows becomes good, and these three which satisfied this condition becomes bad, because this condition unconditioned return true supposed to be good, but because of not, the true is reversed and the if condition returns false, so false clause is executed. So this is the core concept behind it. You can play around with if and or not, all these things. This is fundamentals, it's very basic, let us not focus much on that. So this is why you use the logical condition. Let's move this one aside and let's bring another example, the interesting factor about switch. The switch statement is used to check multiple conditions. So now you see if condition you checked one or two conditions is fine, but sometimes if you want to use multiple conditions, like the switch can be used in creating columns for, if say for example, let us take dim date. If the month number, okay, where is the month number, where is the month year, month number year, okay, here it is, month number of year 7 8 6 7, like that, it's keep on going. If it is 7, then generate it as July, something like that you want to generate. Assume that English month name is not there, so you can start writing it over here using a switch statement. Let us try to write some quick column here. This is like new month name, okay. In order to write multiple cases, switch off, you can say month, you can refer that column number here, column name, month number of year, comma, okay. If it is 1, then what you need to do, it is Jan. If it is 2, then it is Feb. So like that you can keep on writing until 12, right? So for time being I'm not writing that. By default if it is false, then make it as 0, like that. So you can have multiple columns here, conditions here. Expression that yield variant data type cannot be, okay, here you see I have made January February as the value, but at the else case I have put 0, it is not the true thing. So the default month should be, if I'm not specifying anything, it should be NA, something like that. Okay, not available something. So when you press enter, now you can see, because of these months are 7, I didn't put. Let us try to introduce for 7. I will make 7. I will say June. It is June, July, May, June, July. Okay, it's July. Let me put 7 for it. You can see it is satisfied. The 7 for 7th month July is satisfied. For other months I didn't specify the value. For 8th month, so there is no value here. So like this, you want to have multiple conditions, you can use it, this switch statement. I want to give you another interesting example of switch statement where we will remove this, or we will keep this table here for time being, so it will not disturb our current focus. Remove this, where I have interesting case here. You can see, based on the requirement is like, now this particular card, data card, can able to show only one measure, right? You can see either the sales amount. I will try to have the sales amount here, and I can have the quantity over here, sales quantity. Where is the sales quantity? I don't have any measure for it. Let me drag and drop directly here, or I can create one measure very quickly. New measure, it can be anything. Okay, I'm just saying for your example, any measures you can able to show. So basically what I'm trying to convey here is like dynamic measure selection. That is what I'm going to use using this switch statement. The another example I'm going to give. So this is sum of quantity. The name already exists. No, that is fine. So it is order quantity. Now I'm using this order quantity. So this actually what I'm trying to convey is like, this is defaulted, one measure is placed here, this is another measure placed here. Now based on selection, okay, user has to see the different measures here, right? Different measure value. How to achieve it? So this can be achieved using the switch statement, right? So for that to happen, we need some metadata table before creating such measures. This is the prerequisite. So as you can see here, this is created using DAX again. So what I need is like, you can see measure ID 1 and 2, sales amount and quantity. What I'm trying to achieve it here. So I will have this measure list name in my filter. This is my filter. I can have it here. Okay, I think you can able to see it. Let me increase the size if it's not able to visible properly. So this is what it is. So when I choose quantity in this data card, I want to show the quantity. If I choose sales amount, I want to show the sales amount. This two I have referred for your reference. So how to write a measure for it? So basically we need to use the switch statement. For that, let us go to new measure, and let's say sales amount or quantity. Okay, sorry for the spelling, it's okay. Now I will start writing switch, and the expression is like, I need to get one single value from the filter it has been chosen, right? So I can use the value called selected value. Okay, selected value. There are all other lot of other measures that you can go and refer, but in this example I'm going for selected value. Selected value of sales, not sales, measure list dot measure name. So when what happens here is like the selected value function, whatever you have chosen in this column, that will be pointed here. I mean, that will be act as a filter, and what are the values it will have, right? Either it can be sales amount, that is the value it has been chosen. Once it is chosen, what values to be displayed? I want to display the sales amount measure, that is total sales. So you can use the total sales measure here. Next, I will use the, let me put enter, then you will start writing quantity. Okay, once you start entering it, we have just created another measure here, that is quantity measure. So what we are instructing over here is like, if whatever value selected here in this particular table measure name, if it is the sales amount, okay, whatever these are the list of values present in this table. If it is sales amount, you show me total sales measure. If the chosen value is quantity, you show me quantity measure. That is what we are instructing. If nothing is chosen, make it as 0. That is the default value. Let's try to see how it behaves. So I will unselect this and I will use the sales amount or quantity measure. This is the measure we have created. We can drag and drop here. Now you see there is nothing is selected, and which is defaulted as the 0 value. Okay, now when as soon as I choose sales amount, you can see this value is appeared. This value, as you remember, which is using the total sales, right? So this is value appearing. When I choose quantity, you see this quantity value is appearing. So when I choose nothing, it will be nothing. So this is how you can dynamically work on different lists, right? I mean, you can, this measure can be used across any charts as well, right? So it can be used against the charts over here. What do you call I can use sales amount against any of the product. You can see from model name, whether model name exists. Yes, it or I can go for a color by default, or I can go by class. This can be used. Now when I choose quantity, you can see the quantity value against the each class. When I choose sales amount, this will be showing me the sales amount each class against each class. So it can be analyzed across any dimensions you have. It not only class, it can be against the customer or the date or the country, anything that you wish to. That is what it is. So once you write a calculation, it will be more into dynamic value. I hope you understand when to use this logical statements with some of the examples that we have seen today. Let's move on to another list of functions. In this session, we will discuss about relationship functions in DAX. What are those functions? You can see it here: cross filter, related table, and use relationship. Let's check it out. What are those functions, when it will be useful? We will check it out with some examples. I'm in Power BI now. Now we have seen a lot of functions which is having logical or filter, time intelligence functions. Mostly it is based on a single table. Now I have a scenario. What I want to know from here is like, I have this region, that is territory. In each region, I want to know how many products has been sold, right? I mean, instead of products, in each region, what are the distinct colors has been sold? That is what I want to understand now. What I'm trying to say, the relationship between the sales territory and fact, there is only relationship between these two. And you see here, from the product, the filter applies from towards the fact table, and even sales territory applies here. but I want to do comparison between sales territory and dim product, okay, without intervention of this fact. So how you can do that, right? This is what we want to understand it. Basically, like whatever calculations we have seen till now, all are based on the fact table. You are calculating something, what is my sales amount, what is my quantity, everything is based on the fact table. So any dimension you filter, if you apply filter here, then the filters are, it will be, the fact table will be filtered, and if you apply any filters here, that will also be applied. So the filters apply towards your fact table. But now the case is like, I want to see how for each country how many distinct product with different colors, right? Say for example in United States there are 5 colors, the products with total distinct colors sold is 5 colors. Like that I want to understand. Okay, this is the case. Now how we can achieve it? Let's try to get this list by, I have this region, that is each region over here, and let me go here and get the product list, that is count of distinct color. Instead of that, I will go to that later, and I will drag and drop the color here, and I will put distinct count. Okay, count distinct. What happened here is like, there are 10 distinct colors which is repeated for all possible combination. Why? Because you used one column from here and distinct color. There is no relationship between these two, right? If you see, the filters propagate from this dimension to fact, and here this is applying from dim product to here. Only filters applied towards fact table. There is no filters applied. Once you apply here, it will not reflect dim product. That is the issue. Then how we can achieve it? Now what the solution is like, you need to enable this as the two-way relationship. Let me do that. So any filters applied here will propagate from fact table to your product. So let me do the cross filter direction both. Okay, now once I apply this, what happened over here? Now you can see this filter is propagated. Once you apply a filter, each country filter applied towards a fact table, and this filter applied towards the product also. So that is why you get the distinct product. In each country, 8 distinct color products has been, products with different total 8 distinct colors has been sold. So this is what it is, right? But as we're conventionally we are teaching you, like in theoretical, that should not be bidirectional. It is the performance deficient. So what you need to do it in that case? We need to use it using a DAX. That is where your cross filter function comes into picture. You see the formula for this, like I want to calculate the distinct count of colors, and I use the cross filter. Okay, cross filter, what it will do, it will enable that relationship only for this calculation. So you see the formula here, cross filter, I will say left hand side column and right hand side column. You see the definition, cross filter, you use the fact table product. Okay, product key, you see the definition here, left column, right column, and cross filter type, whether it should be both left, right. There are a lot of options. For now, for simplicity, I'm not going digging deep into it. I made a separate video regarding this cross filter. You can check it out in the DAX playlist. Now using this, I am enabling cross filter. From what direction you need to enable? I'll say both. Okay, once I do that, press OK, then click on enter. Okay, so this is the formula. Now again we have removed this direction, that's why the count says 10. Now I use this measure here. Now you can see the result, whatever we achieved when we got it using enable the both direction. We enabled both and we received this result in the count of distinct colors. But now using this measure, that newly written measure, we achieve the similar result. This is the concept behind cross filter. You can do the different direction. You can see the options available here: left, none, both, one way, left filter, one way, right filter. Like that you can enable. This is the main purpose of the cross filter. So you virtually enable for this calculation, because this is used only for certain calculations. Then you can make use of that function. Let's move on to another function called related, when we can use it. Let's get rid of this, and we will say, so related function. So when it is used, like, let me have another case now for related function where I want to understand, I need a data in this sales table, whichever sales happened after 2014-0101. I have a data on till 2014 only, so I'm having that case. So I need the data from 2014-0101 greater than or equal to, and in the country called Canada. Okay, that is what I need. Now how I can get that using I need it in a card. So one way of doing is drag and drop and filter different dimensions. But if you want that same calculation used in different places, it's better to write a DAX. That is what I am teaching you from the beginning. So let us try to write a DAX for it, and we will see what issues we'll get. So what is my concern? Sales 2014. Okay, and then I need Canada, so I will name it like this. So calculate again sum of sales amount, start writing it, sum of sales amount, close braces, alt enter, then comma. Here I use the filter fact internet sales, comma, that is, I have order date key, so I can make use of that order date key greater than equal to 2014-0101. Okay, just for understanding. Now what is my second condition? This is fine. What is my second condition? When I use the country, right, the dim sales territory, when I start typing dim sales territory, it will not appear here. Why? Because when you use a table here, will filter of single table, it will always expect any column reference within this table only you can able to refer. So you see, I will typing country here, it will not display any of the country. This is displaying all country sales is a measure. So in order to get a reference to another column, that is a related table column for this table, you need to use the related. That is the concept behind it. So related, when you put related, then all the columns or all the tables related to this fact table will be displayed. You can refer any one of the column. Using this related function, I am referring now the country column from the dim sales territory. So related country equals Canada. So this is how you can refer the column. Basically related is used to refer the related column or related table column of their table. Okay, that is where you will use it. So you can use in any one of the reference wherever you use in a filter or any table context, right? I mean, when you refer a table, you want another column of a related table, then you can use related. Once you press enter, I will say Canada. So 2014 Canada sales, when you click on it, you can see 2014 Canada sales. So you might have wonder whether this is correct or not, right? So for that, let us take this, okay, and go back over here, and we will see Canada sales for 2014. For Canada sales, you can see 2014 I've pressed Canada here. This is the reference total sales 9458, which is what we are having it here, 2014 Canada sales. By this way you can ensure this is correct, so you can keep it as none so that the data is tallied. 2458, that is what we are showing here. So I hope you understand concept behind related. When you want to refer another table in your calculation, the related table, then you can use the related. Finally, we will touch upon use relationship, and then we can move on to another function type. So use relationship is used when you have a role-playing dimension. What do you mean by role-playing dimension? You have here you might have understand about the concept of having active relationship, right? You see here this is having thin line that is without dotted, which is having make this relationship as active. So at a time two tables can have only one active relationship. Okay, so this relationship is active. But what happens, this is because the fact order date key is related to dim date dimension. But in the same fact table you have a due date and ship date. One of the solution is like you have a dedicated date dimension for ship date and the due date. That will be too much clumsy. So in order to avoid it, right, we will create a inactive relationship. You see here, using the due date we have created the full date alternate key. Even with the ship date you can create the inactive relationship. You can have any number of inactive relationship. So for simplicity I have used only the due date inactive relationship. So this kind of dimension is called role-playing dimension, a single dimension acting as multiple roles, one as order date, another for the due date. So what is the actual thing you want to understand here is like, if you check out the fact table, you can see order date which has happened on 1st of 28 January 28, but delivery happened on February 9th. So when you analyze this by order date, this record will be shown on January, but when you want to analyze by due date, this record will be shown in February. So the count will vary based on how you are viewing your data. So instead of having multiple dates, you can use it by measures, right? That's what we are going to see now. So let us try to create total sales by order date, total sales by due date. By default, total sales by order date is this, total sales. This is using the order date. We can create the total sales by due date, then we can see the difference. So what we need to do is like new measure. We can create the total sales by due date. Okay, then what you can use, you can do again the calculate. So calculate, as I said, that is the magic function you will use all through your DAX calculations, nothing else. If you learn it properly, then you can make use of it. Sum of sales amount, then now you can see like use relationship. What relationship you need to activate? So the fact internet sales due date key, that is related to dim date full date alternate key. So that is what you need to enable it. So virtually you are enabling in this calculations. So what you need to use is like, you need to use this due date calculations in your tables instead of your, you can see from the diagram. So let's clear off some of the columns. Now why it's not appearing, I hope there is some issue in the relationship, because you should not get immediate response. You can see the due date key, and here it is the date itself different. So it is actual date and you are relating it. I hope we need to click on this. So then you go and choose here what happened here. Use relationship can use only two columns, reference participating in relation. Okay, that's fine. So because now it is not the full date alternate key, it is dim date dot date key. So it should be whatever relationship you have used, the inactive relationship, those columns only you need to use in the use relationship combination. Otherwise it won't work. That is what it is shown. Now once you click on enter, now you can see the difference here. Basically, like what happened, because in the total sales in 2010, whatever happened, there is nothing was delivered on that 2010, everything delivered on 2011. That is why you have like this, right? The total sales is appearing for this. So this is the concept behind the use relationship. Instead of showing you the this is for order date and this is for due date, you cannot have different filters. You can use the same date, one for order date, this by default it will be order date, and if you want to create a due date wise your measure, you can calculate it. That is what it is happen. You can have a look at my DAX playlist about this use relationship function if you want to have more information. We will move on to another DAX types function like text functions. Now it's time for us to discuss about text functions. What are those functions? You can see it from this list. And as usual, like there are a lot of functions and most of them we might not use frequently. And I would say like all these functions use it to concatenate or try to find some search string in your queries, or you want to convert that into some other way, right? You can see the lower, upper, and you get the first two characters use left of two, last two characters right of two. All these things I would like to recommend you to use in the Power Query or push it towards your source system itself, right? That is my recommendation because of the load you going to apply it here will be complex. Once you derived a column, then you can use it. Mostly what I'm trying to say is like text functions used to derive a column, we most probably use it, and in some cases in some of the calculations using a filter function, when you refer a table you will also use these functions. Let's try to check it out in this session. What are these functions is all about, when you need to use it, with some examples. As I said before, we're going to create some new calculated columns using this. So I'm in this dim customer table, and one such example is like you have first name, last name, you need to combine it to get the full name. So let's try to create it. Let's try to create a new column and we can name it as full name. Let's make it full name. Let me make it a little bigger so that you can able to see it. And different ways to combine, you can use the ampersand symbol, but we are going to use the concatenate function. Concatenate. So concatenate, you can see you have text 1 and text 2. You used to join two text strings, only two. You cannot concatenate multiple values unlike in the Excel formulas. I hope there will be 255 text columns, you can combine it in a single command, but here you can combine only two text strings. For that, first name from the dim customer, first name, comma, okay, and the last name. There you go. So this is what concatenate does. You can see here from the output you combined both the values over here. And let's take another example, like I want first four characters, 1 bracket 1 1, right? Within this I need to get it from this phone number. For that you will use like left off. So let's try to do that. New column again. So this is also used in the querying as well, right? While you are querying you in your tables, you want to filter whichever starts with one space bracket, one space, I mean close bracket. Then you can use this phone column, left off phone column, then use this string as a search string. So like that you can use it for a filtration as well. I mean to say, now I'm trying to create a column with the left of 4, but in your querying, in your calculations, you want to filter using such a things, you can also use that left function. Now what I'm trying to achieve, like left, I will name it as phone country. Okay, that is country code usually at the prefix. I thought the first 4 characters or first 7 characters will be the my country code. So dim customer phone. So how many characters? 1 space is 2 3 4 5 6 characters I need, comma 6. So when I put like this, immediately I will get those 6 characters over here. You can see from the result 1 2 3 4 5 6. So this is my left of 6. In order to get a right, you can use the right over here. So this will give me last 6 characters at the as my new column. So you can see from the examples. So this is how you can able to play around with this text functions. You can also use all these functions over here. As I said before, instead of doing it here, you move these calculations at your source system or at the Power Query level. I hope this is clear. We have seen a lot of functions, and there is nothing much we can talk in this text functions. Let's try to move on to our next session. So we have reached the end of the session. So let's do a summary or conclusion. DAX is a functional language, and DAX is used to create a measure, calculated column, or a table. Calculate does all the magic, because whatever you do in your calculations, you use the calculate function that will return the results. All X functions, which are iterator functions that executes row by row. You need to use appropriate functions based on the business scenario. If you want to use the time intelligence, you can go for YTD, MTD related functions. If you want to relate two tables, you need to use either related or use relationship based on your design. So that is what I mentioned, appropriate functions based on the business scenario. And you should also know the limitations of the function. For example, path function not supported in a direct query. So you should also aware of modeling part, what kind of model you are designing, like either it's import mode or direct query mode, and based on that you might use appropriate functions as well. So we can conclude like DAX is simple but not easy, and learning curve is too long. You will become a proficient in DAX, but it takes time. So keep learning. That is the only advice I can give it for you to have a good knowledge in DAX. If you like this video, hit the subscribe button and comment below for queries. Do remember that data is your asset.